Hi Year 11. In this video I will be teaching you the quotient rule and how to use it and in which situations you would use it. So let us begin. The quotient rule is written for you here. dy dx is equal to vu dash minus uv dash divided by v squared. Now I want you to pay attention because this is very similar to the product rule. In the numerator, we have our old friend, vuv. So vuv is still making a reappearance here. It's vuuv, and the dashes are on the second letter, except what's different is there is a minus. Okay, so it's vu dash minus uv dash instead of plus, right? Because the product rule, we have a plus there. And of course, what's different is there is a divided by v squared, right? We have a fraction here, okay? And so this is the quotient rule, and it works the same way as the product rule. We need to find u, u dash, v, v dash, so those four things, and then we substitute them into the quotient rule. And that's it. Of course, there are a few little things to be careful of, but other than that, that's all there is. So let's begin by doing some questions. The first thing to be very careful of is the quotient rule only works if the top thing is u and the bottom thing is v. Yeah, so this is the situation in which you would use the quotient rule, when you have a function divided by another function. Okay, so when you see a fraction of functions, that's when you would use the quotient rule. Okay, so let's begin. Let's write down our quotient rule. dy dx is vuv on the top with a minus, with the dashes on the second letter, divided by v squared. Let's also write down what our u and our v is equal to. So we have that our u is equal to 2x plus 1. Now v is 2x minus 1. We're going to differentiate both of them. When we differentiate u, we get 2, and we differentiate v, we also get 2. So now let's substitute these things into our quotient rule. So we've got vuv on the top, so we've got v, 2x minus 1, times u dash, 2, minus u, 2x plus 1, times v dash, 2, divided by v squared, which is 2x minus 1 squared. When I simplify the top, let's expand. So we've got 4x minus 2 minus 4x minus 2. And the 4x's there, clearly they cancel, 4x minus 4x. And the minus 2's, they combine to give us minus 4 divided by 2x minus 1 whole squared. Which is the answer? Oh, the answer must be incorrect. Sorry, I must have made a mistake. So, looks like our answer is incorrect, because I'm certain that my working is correct, actually. So our answer must be wrong. I must have made a typo, so please do correct that in your booklets. Let's also have a look at part B. So part B works the same way. Let's write down our function, and let's write down what the product rule is. It is vuv on the top with the dashes and a minus divided by v squared. Let's write down what our u and our v is equal to. So u must be the top function. So that's u, and that's v. Now remember, instead of writing the square root, we can write our function x plus 1 to the power of half. And for v, we get x. Well, let's differentiate v first. We just get 1, right? When we differentiate x, we just get 1. When we differentiate x plus 1 to the power of half, the power comes down the front. We've got x plus 1. We minus 1 from the power. And then we differentiate the inside. And we'll just get 1 if we do that. So we're not going to bother with multiplying by 1, right? Because it's just 1. And so now we have the information we need to substitute into the quotient rule. So let's do that. We will get a half x, x plus 1 to the power of negative half, minus u times, oh sorry, I should show my working, so let's actually do that first. So we've got v, which is x, times u dash, which is half, x plus 1 to the power of negative half, minus u, which is x plus 1 to the power of half, times v dash, which is just 1, divided by v squared, which is x squared. So let's simplify this a little. We've got x over 2 times, now let's remember that this minus sign that we see here, that makes this a fraction. So it's actually 1 over square root of x plus 1 minus the square root of x plus 1. And this is all divided by x squared. Right? So now let's actually just focus on the numerator. Let's just focus on this over here. How do I simplify that? Well, in order to simplify that, I need to make sure that the denominators are the same. So what is the denominator? Well, the denominator is 2 root x plus 1. So let's actually multiply our second term here, this term, by 2 root x plus 1 divided by 2 root x plus 1, so that I can make sure that the denominator is the same. So we get x over 2 root x plus 1 minus, now if we take root x plus 1 and we multiply it by root x plus 1, we multiply by itself, the square roots, they cancel. And so we get 2 x plus 1 on the top divided by 2 root x plus 1. And this is all, remember, divided by x squared. And so now I can continue. I now have x minus 2 x plus 1 on the top divided by 2 root x plus 1, and this is all divided by x squared. Now that top thing I can make sure to simplify. So x minus 2x is minus x, and then minus 2 plus times plus 1 is minus 2. And then, well, what about this x squared on the bottom? How do I do that? Well, remembering that if I divide by x squared, I'm actually also just multiplying by 1 over x squared. And so this x squared actually jumps here. And it gives me 2x squared root x plus 1. Right? And if you're not convinced, I can show you an intermediate step here. This actually is equal to x minus 2, x plus 1, 2 root x plus 1. This is divided by x squared, which is the same as, let me write in red, as multiplying by 1 over x squared. These two things are equivalent, okay? And so hence 1 over x squared, that jumps to the bottom, okay? And so this is my final answer. Okay, so I do hope that that was helpful. I will do more examples with you hopefully when I return, but I would like you to attempt some of the following examples. If they are really difficult, which I actually expect them to be, somewhat, I would like you to then move on to the textbook exercise, which does contain a few easier questions. So I hope that was helpful, and I will see you when I get back. Thank you.